All right, thank you very much for being here. I'm going to save the formal introductions for later, and I want to start you off with a hypothetical situation for a little bit. So, congratulations, you've become a manager of a set of developers, right? You have a group of developers under you now, and, well, woohoo, manager, or depending on what you prefer. But, of course, being a company, especially a company in the older days, we want to have some KPIs to measure whether or not you're doing the right thing. And let's start off with some sensible ones, stuff like number of features completed within a given time span, number of bugs resolved. And if we're especially horrible managers, we might add something like, perhaps lines of code written. And if you're sitting here wondering, like, why is that a horrible metric? I have a trick for you. It's called Control-C, Control-V. Right, copy, paste. Brilliant lines of code, but you don't get any value. All right, so good luck, manager. We're going to see how your group of developers is going to score in the next period. But on the other end of the scale, we have another manager for operations. The people that are maintaining the systems and making sure that the websites are alive. And they have a set of KPIs too. Stuff like number of incidents resolved, number of requests that we can fire at an application before it starts breaking down. And most importantly, percentage of availability and uptime. And I don't know about you, dear manager, but I start seeing a problem. Because does anyone know a very surefire, short-term way to ensure stability in a system? Any guesses? You don't make any changes to it, exactly. So we have a conflict here. And what we get in practice, and perhaps you recognize this from reality, is that we get things like runbooks and documentation and all kinds of policies and guidelines and bureaucracy, like we just heard, that's going to get thrown into your face before you can actually make a change to a system. Because what we have here is a little bit of local goals. And local goals, I can tell you, once they become the guiding measure, will lead to silos. And that's what we have here between development and operations. That's a bit of a problem. And I've used dev and ops in this example because that makes sense because of the name. Is it just about development and operations? No, definitely not. That's how it started. What you saw here is the kind of I would say, instigation of the entire DevOps movement. But it's since grown and evolved to encompass also testing, security, architecture, business, finance, HR, you name it, and it's there. It's just that if you try to put that all into a name, you get something like this. I'm not a product person, but I don't think this is going to sell, right? Okay, so we know local goals will lead to silos. What's our solution? To me, we need to come up with something that we can all fit into, something that we can all believe in. And that's usually something like a shared vision, a shared mission, and that goes beyond making money, because making money is a goal. That's what everybody does. We want to have a mission that's for everybody in the company, that you can wake up to and think, this is what I'm going to do. Once you have that shared incentive between these different silos to start performing towards that shared incentive, that's when we start breaking silos. And that, ladies and gentlemen, is the first definition of DevOps that I'm going to give you today. There's going to be two more, so bear with me for a minute. So I said I'd save the formal introduction for later. Let's do that now. My name is Kevin Boots. I'm a senior DevOps consultant at a company called Devon in the Netherlands. And my mission in life is to bring smiles back on the faces of engineers and everybody they interact with. So I hope to see you smiling at the end of this session, right? As you may have guessed, I'm a huge IT engineering nerd. That's why I talk about these things in the first place. But I'm also a craft beer lover, and I can tell you, Krakow, good stuff. And I'm definitely going to visit more of the old town tonight. I'm also a kickboxer, and like I said, never combine those two hobbies. That's, never at the same time. Very bad combination. I'm also a double cat dad, or as in millennial speak, I have 2 fur babies. No real babies yet, but I am a loving husband to my wife, who's exploring the old town as we speak. So she's off having fun, while I do the conference stuff, which is also fun. But jokes on her, I have the credit card. So, All right. That being said, my mission of this talk here today is to give you a few different definitions of DevOps that don't delve too much into the techie stuff, which, even though it's very, very important, I think I want to highlight more the cultural aspect, the behaviors that are effective and that we've seen proven to lead to better business outcomes over the years. So I'm going to add 2 more definitions for you today, because my goal here as well is to give you something you can bring forward to other people. And mind you, I don't mind if you prefer DevOps, Agile, or whatever term or framework. The more important thing is I want you to have a toolbox of effective behavior, effective techniques that we can use to start improving client outcomes. Because that, to me, is what the goal of a good framework should be. All right, let's move on a little bit. So, oh yeah, I had a little video. I don't know if you know this one. People are scared of technology. Technology. So I want to stay away a little bit too much from the technical jargon. Now, why am I standing here and trying to give you multiple definitions of DevOps? Right, that sounds a little bit weird. And this is the one that we use at my actual company, where I come from. The reason for that is, compared to stuff like Agile or Scrum, you can always go back to a single document and check, is there anything in there that is going to help me? With Agile, we have the manifesto. Scrum, we have the Scrum guide. DevOps doesn't have that. It grew kind of organically, grassroots. Multiple people around the world, around the same time, had these ideas of, what if we let people work together? Revolutionary idea, I know. But it's way more difficult than it sounds. So there's a blessing and a curse there. A blessing in the sense that this is something that can evolve over time. It's also a curse because I can ask 100 of you, what is your definition of DevOps? You'll all have a different answer. And that might get confusing, especially when you start needing to explain to management what DevOps is. And they already have this idea in the back of their head that 99 times out of 10 is not really correct. So this is another one that I think hopefully highlights both the technical aspect and also the cultural aspect, but both the first one and the second one are still a little bit meager, right? It's the elevator pitch of the elevator pitch. And you can use that to quickly pull out, and this is what it's about, perfect. But I want to dive a little bit deeper with the last one. And I'm going to go back on my word. Know how I just said there's no one document that describes what DevOps is? Well, I'm going to throw 2 in that I believe you can perfectly use as your guide to get where we need to go. And those 2, if you visited the library, I saw at least one of them already. Those 2 are the Phoenix Project and the DevOps Handbook. And if you have room for a third, I would definitely recommend Accelerate, which is the science behind which behaviors lead to good business outcomes, which behaviors are correlated with good business outcomes. Yeah? The first 2, Phoenix Project and DevOps Handbook, by mostly the same authors, describe something called the 3 ways. You could see those as kind of guiding principles that together serve as our kind of code hanger where we can hang all the effective behaviors, techniques, and culture bits that we want to see that we know can lead to better business outcomes. And I want to go through those with you a little bit. The 3 are flow or systems thinking. If you're comfortable with lean or Kanban, this is your place. We have feedback or amplifying feedback. And the third one is continuous learning and experimentation. Let's take a look at what we have. So I've drawn a line here from left to right, from dev to ops, from business to customer, you name it. The first way of flow is about identifying what our system looks like. What is the flow of information from an idea all the way to value in the hands of the customer? That sounds simple, but it actually isn't, right? If you compare this to, for example, the car factory, the flow of information, the flow of value is quite visible. You can walk across the factory line, you see slowly but surely a car being created at the end. With software, it doesn't really work like that. At least I've never walked into a room and saw bits and pieces of floating code clicked together like Tetris blocks. I wish I could. Would be a nice app to design, actually. Any product designers out here? But it's essential that we start identifying what is the flow of information within our company, within our value stream, you name it. And the first key, well, you've had a keynote yesterday on visualization. Visualize. On 2 axes, we can use stuff like boards for our daily work, Scrum board, Kanban board, you name it. The second is what I'm showing here, something like a value stream map, and compared to the ones we saw yesterday, this one is quite shitty. I'll publicly admit that. But what we essentially try to do is to have enough people in the same room that know something about how information flows, know something about which activities we need to do to get from left to right, or from left to right for you. Once we have that, we can also start measuring stuff like process time, so hands-on time. How long does this activity take, and how long is the time between activities? Or if we listened to the keynote yesterday, also the human factor, which I think is a very nice addition, or perhaps even a replacement. Just the act of doing that helps ensure that the people within our flow, between these different silos, start gaining an understanding of what is necessary to get stuff done. I don't know about you, I often hear discussions of, yeah, I don't know what they are doing. And that goes from developers, testers, operations personnel, architects, security personnel. And we need to get rid of that. This is a tool that helps you gain understanding. It also helps you start identifying where possible bottlenecks might be, but I'll get back to that as we go. Once we have identified what that particular flow is, we have a few lean techniques that we can use to start improving it from the onset. First of which being limiting work in progress. I try to do 10 things at once, slight ADD problem, and none of them get done. If I start doing one thing at once and finish it before picking up something else, I become faster. You can play something like the Agile coin game or the lean coin game, if you've ever heard of that, to really get that point across. Same goes for reducing batch sizes. Instead of trying to push out 20 changes to a customer at once, which is often a stressful affair, and you can guarantee that something goes wrong. When something goes wrong, you need to start figuring out which of the 20 changes was wrong. But in that process, you'll likely have to reverse all of them, rework, and then send it back again, which is a wasteful process. If we try to do it one at a time, our delivery becomes faster, it becomes less risky, which is one of the key pillars, I would say, of adopting something like DevOps, reducing risk, making things easier, and we become faster. Also key here is reducing handoffs. So each time you hand off a piece of work to someone else, you inevitably lose speed because you have to wait for that person to be ready, and you lose information. Because there's something here in your head, you've written a piece of code, for example, you know why you wrote it the way you did. The person after you likely doesn't, unless they can read your mind, in which case, perfect. So reducing handoffs across our system is one of the key pillars here. And finally, remember how I talked about bottlenecks just now. If you have that value stream map or something similar, a visualization of how stuff works, you start recognizing, hey, wait a minute, there's a few points here that really limit our speed, our flow. There's something here that's not right. I wanted to introduce to you something called the theory of constraints, written in the book The Goal. And it states, very simplified, that there's, in any given system, in any given flow, there's one and a maximum one biggest constraint on your system, the biggest bottleneck you have. And your best option of improving your flow, what the goal of the first way is to pick up that bottleneck, resolve it, measure if it worked, because you might have some unexpected effects here and there, rinse, repeat. This is a small toolbox that you can start using already on your flow to check, hey, are we doing the right things or are we making things too complex, like we just heard. So that's one. Let's go to feedback instead. And I'm curious, this is a question for all of you. You can just shout at me, I don't have chocolate, sorry. But you have my eternal gratitude if you do. I hope that's similar. What kinds of feedback do you know? Sorry? Kanban boards? Yeah, absolutely. Sprint review? Any others? Production alerts, monitoring, logging? Absolutely. How about things, sorry? Code review? Yes. Peer reviews? Testing? Absolutely. Yeah, we're already getting there quite well. Nice. Yeah. It's very fun if we have that flow from left to right information. What we also need to do if we're know if we're doing well, right? So the second way of feedback is about connecting the loop back from right to left. But not just from right to left, it's also in between every state that we do, between the left and the right, creating and amplifying feedback loops along the way, like code reviews, like peer reviews, like testing, like monitoring, logging, on-call services are also a very good form of feedback. If you get called out of bed at 4 a.m. because of a production incident, I'm quite sure you're going to use that feedback to improve your system because you don't want to be called out of bed at 4 a.m. again, right? And the goal here is to create an ever safer system to change. Why is that important? Well, the second pillar of feedback is that we want to see problems as they occur. The worst thing that can happen for us is that there's an incident that we could have caught way in a development phase, for example, but it ends up into production, we get called by customers, they get angry, and those kinds of things, right? Ideally, we want to see a problem the moment that it becomes available in the system. And we use our feedback loops for that. So things like testing, like reviews. Ideally, you have continuous reviews, so something like pair programming is really effective, it turns out, in preventing rework. That's already something that you can do in order to start improving the feedback in your system. The next one is swarm and solve. And how many of you have heard of something called the Andon cord? Yes, perfect. The Andon cord is something you will find in the car factories of Toyota, where initially the ideas of lean and Kanban started popping up. And this is a cord, or sometimes a button, that all employees in the factory are instructed to pull the moment they suspect something is going wrong. So they don't even need to see something going wrong, suspecting is enough. What happens is that the entire factory line is stopped, and that person has about, I think, half a minute, if I remember correctly, to try and fix the problem that is there. To prevent it from progressing downstream, where it starts becoming more expensive, harder to fix, right? If there's a defect in a car, you need to recall it, that's a shame, a hassle. If you can solve it on the spot, perfect. If they cannot solve it within that half a minute, they don't restart the factory line. In fact, they ask everybody on the work floor to join at that spot and to see what's happening, to come up with solutions together, to brainstorm. And that might sound like a waste, but what do we do if there's a major incident? We gather all the people that have knowledge of that problem or could have a solution. We gather them, we put them in one room, and we let them brainstorm. Same thing applies here. As it turns out, there's two benefits to this, at least. One, more ideas, more creative solutions of trying to solve the problem, which is good. So you resolve the problem faster. Two, everybody on that work floor is going to walk away with the knowledge of that solution. Meaning, next time something similar happens, they'll know what to do. They'll pull the cord, have 15 minutes to fix, and then it goes on again. And that benefit is way bigger than you realize. So within a team, good behavior would be, we have an incident, everybody swarms, stops what they're doing, fixes the problem, and then resumes the rest of their work. Okay? Another important pillar here is if we start improving, creating, amplifying feedback loops, is that we start trying to pull activities that we usually do way at the end, so we do them less often, because usually they're hard or they're not very fun. A common example I use is something like a security review. We tend to pull that off until the end, right? We don't want to have CISOs with their checklists. And what we can do is something called shift left. So introduce certain types of feedback loops, certain tools, certain scans that we can perform very often and very early on in our process. Stuff like security scanning or composition analysis. So that parts of that very big, hard, nasty feedback loop way at the end is broken up and pulled more to the left. So we start doing it earlier, we have our feedback faster, and we can fix things faster. And that CISO at the end, who is sitting there with his checklist, is like, oh, wait a minute, you've already covered like 90% of this. Okay, nice. That's a concept called shift left. And then finally, one thing I do want to mention is that when you start creating feedback loops, of course, except the things like peer reviews, code reviews, which are inherently manual because they're human, rely on automated testing as much as you can. Start investing in that small bits at a time, but build that system up over time. Why do I say that? Let's go back to the car factory example. Let's assume we have a factory line with modules that don't control anything, don't check anything once they've put parts of the car together. Just done. At the end, a car rolls off, hopefully, and an inspector comes by and looks at it and is, yeah, that's a car. Okay. What did that act of the inspector do to the quality of the car? Nothing. At most, it confirmed what was there. And there's a time and place for that. The comparison I'm trying to make here is manual testing. There's a time and place for it, or certain feedback loops have to be done manually, but nearly not everywhere. Let's compare that to an example where we have these modules that are putting together a car. And with that come quality modules that scan for certain distances. This part needs to be installed with that much space between them, et cetera, our automated tests. What does that do? It raises the minimum level that we know is going to be in the car. Every investment you make there is an investment in raising the minimum quality you know to be there in your product. That's why I say rely on automated testing as much as possible. Also because having to do the same test 30 times per week is just plain boring as a human. But that's me. All right, so we have a few concepts here for feedback. Now there's one more, and this is my favorite. The third way, continuous learning and experimentation. And to get us started there, I'm very happy with the keynotes we've had because they touch upon all of this. And for the people that are going to the psychological safety workshop, implement what you're about to hear. Or I think you're going to go way further than what I'm about to tell you. But I have a story about a company called SolarWinds in the US. Anyone familiar with that company? Slightly? Then you might know where I'm going with this. So they are partially responsible for the safety of the American government's mail servers. So no big deal, no safety issues whatsoever. You can imagine that that makes them quite a popular target for hacks. And they've been hacked a few times over the years. I mean, at some point it's inevitable. But there was one quite egregious example where they found out that part of the possible reason for the hack was a certain password. A password to get into a management system that you could then use to jump into the rest of the systems of SolarWinds. Perfectly fine structure to have, nothing inherently unsafe about it, unless you use a password that's literally SolarWinds123. That's something you could brute force in, I think, 2 or 3 days. Thing is, it didn't even need to be brute forced because someone put it on a GitHub repository for everybody to see. It's never been officially confirmed whether or not this has actually led to the hack, but I mean, it doesn't take a genius to assume, right? So, okay, stuff happened. And yes, this is an egregious example, but still, like we've heard before, we have to deal with complexity. Complexity means there's going to be incidents. So, okay, how do we react to this? CEO of SolarWinds was pulled into Congress to answer questions because you can imagine they were slightly mad about this. And the reaction of the CEO about the entire password debacle, in which one of the famous quotes was from a senator, "I think I use a stronger passwords to keep my kids from watching YouTube too much." Perfect. The quote from the CEO as a response to this entire incident was, "Yeah, an intern did it." So, next time you work at SolarWinds as an intern and you make a mistake, what do? Door's over there, I'm gonna go there, bye. One of the fun side effects is that for a few years, no interns wanted to work for SolarWinds anymore, because you're the next one under the bus. But from a DevOps standpoint, and I think from a psychological safety standpoint in general, this was a terrible, terrible, terrible decision. When we're looking at the third way of continuous learning and experimentation, the first pillar is creating an environment where it's psychologically safe to make mistakes. And one of the best ways to get started doing that is doing good post-incident analysis. An incident analysis like post-mortem or root cause analysis or 5 whys, whichever you prefer, but one where ideally the sentences like "I'll pay better attention next time" or "I'll do my best next time" are well-intentioned, but a little bit useless. What we want to have is a situation where it's okay to make these mistakes, where we can analyze them, where we can ask for information about them, and start coming up with solutions that we can build into the system that prevent us as humans from making that mistake again. If I take the SolarWinds case, a few suggestions you could come up with is, hey, how about we install better password policies so we have a stronger password next time? Another one is this intern, if that's actually the case, felt the need to write it down. Where's our password management systems? Our key vaults where you can put them in and store them safely so you don't have to write them down in your code anymore. Or another one, because again, accidents happen, how about we have some secret scanning on everything that we put into our systems, and if something looks like a password, you get an alert. Like, wait a minute, with saving this, are you sure? You may be saving something that's a bit critical and that you don't want to have in public. So that's one. The second is that we try to make the improvement of daily work an institution. Or a quote by Toyota is, the improvement of daily work is more important than the daily work itself. Well, tell that to the average product owner. You're going to have a bit, what do you mean? One of my ways of making this practical from a leadership perspective is to institute something I call the 70-20-10 rule. 70% of the time of a team goes toward the daily work, so features, incidents, those kinds of things. 20% of their time goes to process improvements and tech debt, if they have any identified. There's always tech debt, it's a case of identifying it. And 10% is self-study. What helps you become better at the work that you do, or learning more about the work that people around you do. I've heard one case at the speaker's dinner where the team decided to use that 10% of the time to just go drinking every Friday afternoon. I would choose for somewhat more sustainable solutions, and that's coming from me as a craft beer lover, but you know, you do you. So that's 2. Okay? Then, local discoveries become global discoveries. So use whatever you have identified in, for example, post-incident analysis, and share it with the rest of your company. Because just like with the swarm and solve example, perhaps your solution helps a problem that someone else is having in the other corner of the company. The reverse of this is that you see multiple teams trying to tackle the same problem, coming up with 5 different solutions, and then meeting in the end and being like, yeah, but which of the 5 are we going to use? Which is reinventing the wheel all over again. And that's a shame, right? So when you're at a certain point, you've taken all these 3 ways in parallel, you've instituted certain behaviors and techniques, and you see a lot of improvement, and you suddenly see this improvement slowing down. Right? People start running out of ideas of how we can further improve, then it's time to start raising your standards or lowering the boundaries of what you find acceptable. How many of you know something called the chaos monkey? Ah, that's more than I expected. Nice. So usually I preface this with asking, do you know what Netflix is? Well, 5 years ago that was a valid question. Nowadays it's a little bit, duh. But they used to have an application called the Chaos Monkey, which would go into their data centers and simply start pulling cables at random moments of the day, randomly turn off stuff, and then leaving it for the engineers to solve it. So it didn't matter if it was a front-end, back-end database, didn't matter, just pull the plug at 4 a.m., who cares? That did 2 things. The engineers of Netflix needed to solve the immediate problem, and through good post-incident analysis, they came up with ways to make sure that the next time something like that happens, it didn't become as much of a problem anymore. A practice called chaos engineering. Mind you, they did this in production, and I can imagine that for a lot of our companies, that might not be the best idea to start pulling plugs out of production systems, but the idea of this, also called resilience engineering, is something you can perfectly use once you've run out of the quick wins and the major wins in your system to start lowering your boundaries even more and start identifying even more improvements you can make. Looking at the time, I'm going to switch a little bit further, but the last thing we want here is for leadership to facilitate experimentation. Do hackathons, have communities of practice, make sure people can spend time on this stuff. All of that is going to come back to you in ways that further make the work on your product, within your companies easier. Normally I say cheaper, faster, and less difficult. I don't know about Polish culture. In Dutch culture, most people interpret that as, oh, so now I'm being expensive, slow, and bad at my job. So I tend to talk about easier. But that is the 3rd way of continuous learning and experimentation. So, What have we learned today? I've given you 3 different definitions of DevOps. First, breaking silos. That is what it's about to me. We can leave all the technology stuff behind. It's important. Again, huge engineering nerd. We need to learn about this, but it begins with breaking silos and aligning to shared goals. The second is make sure that you craft your own, like we have within our company, but decide for yourselves within your own context what it should be. Something like DevOps should be within your own companies. And the last, if you need a starting point, definitely look at the Phoenix project or DevOps handbook. They're over there in the library. I know you can pick them up. Please do. They're brilliant resources that are well researched. So, I've tried to explain DevOps to you in a way that hopefully didn't scare you. And from now on, I think so can you. Thank you very much.